and welcome to a movie all about covalent bonding. Before we can do anything with covalent bonding, we have to talk about dot diagrams. Dot diagrams represent the number of valence electrons around an atom. Basically what that means, if you were to draw a Bohr model, it'd be the number of electrons in the very outermost ring of an atom. It's important to know the number of valence electrons or valence electrons because it really deals with covalent bonding. In order to draw a dot diagram, what we need to know is what family number the element belongs to. We have 8 families that we'll be working with today. Let's start by taking a look at hydrogen. As you can see, hydrogen belongs in family number 1. If you find hydrogen on the periodic table and look up, the number 1 is listed above it. This means that hydrogen's dot diagram would have an H representing hydrogen and 1 dot, representing the 1 valence electron and showing that it is in family number 1. Awesome! Let's try another one. Let's take a look at one called neon. If you find neon on the periodic table and look above it, you'll see the orange number 8. That means that neon belongs to family number 8, and that it will have 8 dots or 8 valence electrons around it. In order to fill in a dot diagram for neon, we'll start at the top and we'll add our dots one at a time on each side of neon until we've reached 8. Eight is the maximum number of dots for a dot diagram, so neon, we say, is full. Let's see now if we can do one for nitrogen. Nitrogen's symbol on the periodic table is N, so we know that we'll have to find N on the periodic table. When we look above nitrogen, we'll find what family number it belongs to and determine how many dots nitrogen needs for a dot diagram. It looks like nitrogen has the number 5 above it, which means we're going to need 5 dots in our dot diagram. Let's start by drawing an N. Here's an N to represent nitrogen. Now, we need to add the 5 dots. I'm going to start at the top. 1, 2, 3, 4, and back to the top. 5. This is a dot diagram for nitrogen. Now it's time to talk about covalent bonding. Yes, the fun stuff. Basically, every element wants to be full, or have an outer ring that has as many electrons as it can hold. Most elements, except for hydrogen and helium, want 8 dots on their dot diagram, or 8 valence electrons. Once they have 8 valence electrons, we say that that atom is full or stable. We already drew a dot diagram of nitrogen, but let's look at it one more time. For nitrogen, we have to draw our N, and we know that we need 5 dots because it is in family number 5. 1, 2, 3, 4, 5. The problem with nitrogen right now is that it's not full. It can actually hold 8 electrons and it only has 5. So nitrogen really wants to get 3 more electrons. This is where bonding comes into play. Now we can have an element share with nitrogen in order to make nitrogen full. So let's take a look at hydrogen. We drew a dot diagram for hydrogen earlier too. Hydrogen's dot diagram was an H, and it belonged in family number 1, so it has 1 dot above it. Now, hydrogen could share with nitrogen to help make nitrogen full. Let's take a look at how that might look. Alright, so nitrogen starts with 5 dots. 1, 2, 3, 4, 5. Now, hydrogen has one valence electron, or one dot. So hydrogen could share its electron with nitrogen. Let's say that it's nice and decides to share. So our hydrogen comes and shares its electron with nitrogen like this. I'll make hydrogen's dot diagrams colored in so you can tell the difference. Now nitrogen has 1, 2, 3, 4, 5, 6 dots. We're closer to 8, but we still want 2 more dots. So let's bring in another hydrogen. Here's one hydrogen. It will have 1 electron because it's in family number 1, and it's going to share its electron right here with nitrogen. Now if we look, nitrogen has 1, 2, 3, 4, 5, 6, 7. We're closer. Let's bring in one more hydrogen to this game. Our last hydrogen is going to go at the bottom. It's going to bring its 1 electron to share. And now, if we look at nitrogen, it has 1, 2, 3, 4, 5, 6, 7, 8 dots. Nitrogen is full. So this would be a covalent bond. 3 hydrogens came to share their 1 electron with nitrogen so that nitrogen could have 8 electrons. Awesome! Let's try another one. Nitrogen and 3 hydrogens, like this, is actually written as a compound NH3, meaning 1 nitrogen and 3 hydrogens. NH3 actually is ammonia, which is found in Windex.